take a look here. We're on in Standard 13 right now, and Standard 13 is Lesson 11-6, Rational Expressions with Like Denominators. Now that's the easier kind to do because when the denominator is the same in the bottom, it makes it a lot easier to do the problem. For example, this is example 1 on page 608, which we did in class today. All you have to do on this, if you were to rewrite this problem, you can take that denominator, 12, and just write it one time. And then you can take these two like terms, the 3n and the 7n, they're like terms because they both have an n. You just add them up, 3 plus 7, and you get 10n over 12. You're almost finished there, so here's what you have to do, and that is to see if you can reduce anything. So what we'll do here is reduce the 10 and the 12 by dividing by 2. When you divide by 2, you get a 5 here, and you get a 6 down here. So to write the final answer, all we have to do is write our 5, keep the n that we had, and it's over 6. And that would be the answer for that, the FA. Then we move over to number 2. It's the same kind of problem. Notice that the denominator on both of them is x plus 1. So we're going to rewrite this problem also this way. Put the x plus 1 on the bottom. But now we have 2x plus 2, and we can put that all on the top, 2x plus 2. Now there is one additional step on this problem because this 2x plus 2 is something that we can factor. So we look at the 2x, which is one of the terms, and the other term is the 2, and we notice that, oh, there's a 2 in both of the terms. So we can now extract or take out the 2 from those two terms, and then we set up parentheses for the rest of what's left over. Inside the parentheses we put what we didn't put out here. So what is left here is the x, and then here we do 2 divided by 2 is 1, and so we put plus 1. So we have now factored the numerator of the problem. We put that now over the same denominator that we started with, which was the x plus 1. And at this point, we look to see if there's anything that we can cancel out top and bottom. You'll notice that we have the x plus 1 here and the x plus 1 at the bottom. They are a team. They go together because they're joined by the plus sign. So we cross out the entire x plus 1 here and the entire x plus 1 here. The only thing that's left is the 2, and that means that the answer is 2. F-A.
Fat animal.
Fat animal, funny answer, whatever you want to say, but that's the first 2 examples. Mr. McCaffrey will take over now and do examples 3, 4, and 5.
Here we go. So now we're on page 609, example number 3. For those who don't speak Spanish, that's number 3. All right. So here we have this rhombus. This is basically a cricket square right here. And they're asking us find the perimeter. Let's just do a little review real quick. Say if I give you like this little square and I said find the perimeter of it. So if this was 5, well, if it's a square, then they're all 5. And the perimeter means find the length of the entire object if you were to add all of them. So you would add 5 plus 5 plus 5 plus 5. Okay, you add them all together, which will give you 20. So the perimeter is when you add all the lengths of your object. So you do a square, triangle, rhombus, kite, and whatever else you want to do here. So in this case, oh, I didn't miss very well. It's all right. We have a rhombus here. And they don't give us nice, easy, first grade kind of numbers like 1, 2, and 3 and all that. But they give us this length is 4a plus 5b over 3a plus 7b. And this length is 3a plus 3b all over 3a plus 7b. So this gets pretty hairy here. Well, check this out. If we want to find the perimeter, that means we're going to add this length and that height, this length and that height. Well, because it's a rhombus, they're going to be, this is the same as that side. So I could also label this side as 4a over 5b all over 3a plus 7b. And if this side is this tamale, then I can say that these two lengths are the same. So this would be 2a plus 3b all over 3a plus 7b. So if we're going to add all 4 sides, we know because we are adding common denominators that our denominator is just going to be 3a plus 7b. Because when you add numbers that have the same denominator, you just keep it there. So because they're the same, that's we know what the denominator is going to be. And now let's just go ahead and combine together our A's, and then let's combine our B's. So I'm just going to put a triangle around our A's. And that means that we're going to combine our A's together. So check this out. We have 4A and 2A. That's 6A. Plus 4A is 10A. Plus 2 more is 12. So that's a total of 12A on top. And now let's add our B's. I'm just going to put a circle around them just to indicate that those are the exact same type of terms. We don't add A's and B's together, only the B's and the A's that go together. So 5B and 3B is 8, and then another 5 and 3 is 8, so we're going to have a total of 16B. And that's going to be it. 12A plus 16B, all over 3A plus 7B. Booyah! Now come on over here to the nerdy classroom, and we're going to do 2 more examples. And continuing on in page 610, number 4A. Okay? So in this case, we're not going to add, but we're subtracting. However, do you see here how we have a common denominator? So we know that our denominator is still going to be x minus 2. Okay? But this little tinkly winkly makes it a little more complicated. And what that means is we need to distribute this negative sign. So we have to distribute it in there and distribute it right there. So watch this. So we drop down our 3x and we drop down our plus 4. But now when we distribute negative x times a positive x, like over the rainbow, negative times a positive is a negative x. And a negative times a negative 1, a negative times a negative, is going to give us a positive 1. So the little trick there is if you have a negative sign, we need to change these signs. So we went from a positive to a negative and a negative to a positive. Now let's combine like terms. 3x minus x is 2x. 4 plus 1 is 5, all over our x minus 2. Oh yeah, I forgot. F-A. What up, dog? All right. Lastly, here we go. So we're on page 610, question or example number 5. So do we have the same denominator? No, mijo, no. We don't have the same denominator. So the trick is this. You see how it's m minus 9, and this one's 9 minus m, so they're just reversed? The trick is we're going to factor out a negative 1. So we're going to rewrite this, and we're going to factor out a negative sign. So just write that negative, and now that becomes the exact same thing as that right there. So you just factor out a minus sign, and then it becomes the same. And then on top you have 4m. Okay? So now we have 2m minus 4m. Well, that's negative 2 all over our common denominator of m minus 9. Yeah, boy, yeah. And that's about it there.